Okay, for problem 1A, for find the uncertainties of 12.36 kilograms, I originally said plus or minus 1, plus or minus 2, but I changed it to plus or minus zero point zero 0.01 because the measurement may reflect an instrument that reads out to an accuracy of like zero point zero 0.01. Or I also did uh, plus or minus zero point 0.1 because the instrument may only read out to an accuracy of like zero point 0.1, and the number was estimated as somewhere between like 12.3 and 12.4. Okay, for problem 2, it says explain how the accuracy of a measurement changes as the measuring tool becomes larger. Give examples and discuss when larger measuring tools are more appropriate than smaller ones. I answered the question, but I did not give any examples. So I said that when measuring something large, such as a football field, there is more room for error when using small measuring tools, such as a ruler. Also, large structures don't take small measurements into account, such as millimeters, because the very act of measuring would introduce errors larger than this. So, number 3 says correct each of the following numbers given the uncertainties. So A is 39.09 plus the uncertainty of plus or minus 0.05. Originally I said 40, but I realize now that it's 39.09 because the 5 is in the hundredths place. B says 19.4906 with an uncertainty of plus or minus 0.002, which I originally said 19.4908, but I now know that it's 19.491 because the 2 is in the thousandths place. And then C says 0.0003995 with a plus or minus 0.00001. I said it was 0.0004, but I know now that it's 0.00039 because you don't round the 9 up. You just take away the other decimal places past the 9. Okay, number 4 says find the width of your desk with the measuring strip provided. Be as accurate as possible given your measuring tool. Given the limitations of metric measuring tools, explain how you went about finding the width. Discuss your rationale behind your chosen accuracy. Originally, I converted it into inches instead of using measuring the paper strips as a measuring tool. So I changed my answer to measured width of desk is a little less than 5 strips. To make this measurement, I laid the strip down, then made a mark, laid it down again, then made a mark, etc. Therefore, I estimated the width of the desk to be 6.0 strips. My rationale for this is that I can only estimate fractions of a strip length of 0.5 strips, and my measurements were much closer to 6.0 strips than 5.5 strips. Okay, number 5 says using your laptop graph following data and then determine the graphical relationship. So originally I said it was a parabolic, which is correct, but the reason really is because it obeys the equation y equals x to the nth power plus b, where n is greater than 0. And what I didn't do is graph it or show a trend line. I mean, I didn't show the equation or show a trend line. Number 6D says, what is the standard conversion factor used to convert kilometers per hour to meters per second? So what I did not do was show how to convert the units by multiplying and canceling out. So I changed it to kilometers per hour times 1,000 meters per kilometer times 1 hour for 3,600 seconds, which gives you meters per second. And the standard conversion factor would be 1 times meters times hours time over 3.6 kilometers times seconds, which gives you 0.278 uh, meters times hours over kilometers times seconds. Number 7 says, which graphical relationship does the following graph represent? I said direct, which I now know is wrong. It's actually linear because it fits the equation y equals mx plus b. It also has a positive slope.